So section 1.4 here, as well as 1.5, 1.6, and 1.7, all the rest of chapter 1 deals with using a number of different formulas for a number of different shapes, some of which you may have some exposure to already, like the area of a circle, hopefully you know the area of a square, a few simple ones like that, and then we extend that into some three-dimensional shapes. Today we'll be looking at, or for this video, these videos we'll be looking at surface area of right pyramids and right cones, as well as a regular tetrahedron. There are other shapes that we'll talk about are spheres and cylinders, and continue some calculations from surface area all the way through to volume of all these shapes. So all of the shapes with the more complicated formulas that you'll need will be they're all included on your data sheet. So you'll see them there on your data sheet. As we work through some of the examples, I've cut and pasted sections off the data sheet in here so we can see the formulas as we work through. But for the most part, they'll all be on your data sheet. I'm going to come back to this square-based pyramid, this one here, as well as these figures back in a second. So just bear with me a little bit. I want to talk about this one particular shape here, though, the regular tetrahedron. This shape is not included on your data sheet, so this is something you have to remember. A regular tetrahedron is basically a triangular pyramid in which all the faces of the triangle are the same. So this side face where the slant height is located and noted, as well as this face right here, the back face here, and the bottom face underneath, those are all the same shape, and that's what's meant by regular tetrahedron, that they all have the same shape. So if we look at example 1 says calculate the surface area of this regular tetrahedron to the nearest square meter. Now remember, area is a two-dimensional object. Surface area is the area of the outside faces of a three-dimensional object. So that's how it changes from area to surface area. So if we're looking at a regular tetrahedron, we know that each of those faces is going to have a triangular shape that looks like this. Now that's not a very well drawn triangle, but I know that the height of this triangle is going to be, as indicated, the height of this triangle is going to be 4.3, and the base length of this triangle down here is going to be 5.0. Now a regular tetrahedron, we have to remember, is four triangles that are all the same shape. So basically all I have to do is find the area or the surface area of one triangle and then multiply by 4. So in this case, the formula for the area of a triangle is base times height divided by 2. But in this case, our height is actually S, or slant height. Now slant height on these three-dimensional objects is the height on that external or lateral face. It's not the internal height from the center of the object up. And when we get into volume and doing some more calculations with surface area, we'll talk a little bit more about that as well. So this actual formula should read area is equal to base times slant height divided by 2. Now that's for two of those, or for one of those triangles, but we know that there are 4 of them. So we just have to remember to multiply our answer by 4. So I substitute in my values. My base is 5. My slant height is 4.3 divided by 2, which works out to 10.75. And then I have to remember that there are 10 of them, or I mean 4 of them. So I take my 10.75 and I multiply by 4, which gives me 43. And remember that area, or surface area, are my units squared. Okay. So there's our first example, example 1, section 4 or 1.4, and come back for example 2 and talk about the square-based pyramid formula.